Looking at properties of definite integrals, and then we're going to use those properties to evaluate integrals. Is what we're looking at today. Okay, it shouldn't be too difficult at all today. So before we get started, we want to go back to the definite integral. We talked about it a little bit yesterday, but we want to go back and specifically talk about each piece of the definite integral. First thing I want to do is notice down here, this is how they have it written, or how they want it read. The integral of f from a to b, but I don't like doing that. I like to say the integral from a to b of f. I think that makes more sense than the way they say it. So when you see something like this and I ask you to read it for me, I want you to say the integral from a to b of f of x. That's what I want you to tell me. Okay? All right, so a would be the lower limit, b would be the upper limit. We have the integral sign. What did we say the integral sign was roughly in the shape of? Because stands for sum. Because yesterday when we were approximating, what did we do? We added stuff up. So that's why it is sum. Okay, the inside piece is called the integrand, and we have the variable of integration. What does the variable of integration do for me? It tells me what variable I'm dealing with. Because sometimes, as you'll see over here, I've got numbers, but I don't have any variables with those numbers. So that means, that tells me when I integrate, if I need a variable, that's the variable I'm going to use. So that's why that's there. Okay? And then when you find the value of the integral, what you're doing is you're evaluating the integral. And that's what we want to do today. Okay? So, let's get started. We're going to do 7, 9, and 11 to get started before we get into the properties, because we should be able to do 7, 9, and 11 from what we learned yesterday. And what were the two most important things we learned yesterday? A definite integral represents two things. Change in the function above and area underneath the curve. Those are the two things the definite integral represents. So, if I'm looking at this first one, somebody read this for me. How do I want this read?
Integral from -2 to 1
5.
5.
Of 5. Very good. Integral from -2 to 1 of 5. We want to evaluate that. Now, what do we say that represents?
Oh, changing the function.
Changing the function above or
Area.
the area under the curve. So let's go with the area under the curve thought. What is my curve? 5. What does the curve 5 look like? It's a line. What do you know about that line? It's straight. What else do you know about that line? It's horizontal and it crosses the y-axis at 5. So there's the function 5. There's my curve. Okay, what do the limits tell me? -2 to 1. So what's the area under the curve going to be?
3 times
15.
15.
Oh!
It's going to be 15. Because we're going from -2, which is right here, to 1, which is right there. So my area under the curve is just that rectangle right there. It is 3 wide and it is 5 tall, so that area is 15.
Well, that's some nifty stuff.
Okay, what about number 9? The integral from 0 to 3 of -160 dt.
What is 3 times
-480. -480 is correct. Why is my answer negative? Yeah, but look at this area. What do you notice about this area versus the -160 would be somewhere down there. We're going from 0 to 3, so that area is there.
Is it because it's below the axis?
Below the x-axis, give me a negative value. I heard you, bro. Above the x-axis gives me
I
a
just want
positive.
my credit, man. That's all.
All right, then what about 11?
0.5.
Why?
I don't have one.
Why?
How far is it from negative 2.1 to 3.4?
3.
5.5. And I need to do 5.5 times 0.5. So what do we end up with? 2.75. So that is what you do whenever your function is what? A number. Whenever it's a constant. Whenever you are integrating a constant, that is the approach you want to use. Okay, so what is our approach? What's the approach to integrating a constant?
Find
Under the curve.
limits.
Find the difference between my limits and multiply times my constant. That only works if you're dealing with a constant. If it's not a constant, you can't do what we just did. Okay? So that's how you integrate the constant. Now let's get into some of the properties of a definite integral. Let's say I have a definite integral. Somebody read that for me. Somebody besides Erica. What is it, Kaylee? Integral from a to b of f of x. All right, so we're going to say this thing is equal to 3. If that's equal to 3, and then I come in here, and then I ask you what this is equal to, what do you think it's going to be equal to?
6.
6 is correct.
Nice.
What is that 2?
Number.
Multiplying.
Coefficient.
Coefficient. It's a coefficient. If I'm dealing with a coefficient, I can take that coefficient out. Okay, and then we know that this thing right here is equal to 3, and 2 times 3 gives me the 6. So if you've got a coefficient, you need to realize that you can factor that coefficient out and then multiply. All right, so there's one. What about what do you think this thing equals?
0.
0. Brady, why does it equal 0? Yeah, I didn't move any. There's no width. There's no width to my area. So since there's no width, that means it's got to be equal to 0. There's no area. Okay, so if I'm going from A to A, it's always going to be 0. All right, so let's say I have A to B of f of x dx, and let's say it's equal to 7. What do you think? What do you say? Negative 7 is correct. So if you change the order of the limits, that's going to change your sign. So A, if I'm going from A to B and that equals 7, that means from B to A equals negative 7.
Why do they want to do
So it's not absolute value.
Say it again.
Why do they want to
Because if I've got top minus bottom, that gives me B minus A. And then if I do top minus bottom right here, A minus B, that's going to give me opposite numbers.
Oh.
For instance, so if I had 3 and 1, if I did top minus bottom, that'd give me 3 minus 1, which is 2. Here, if I did 1 minus 3, that would give me
So it's two,
negative
three,
2.
five,
So if I switch the orders, that's going to change my sign.
advertise?
Alright, let's say I have the integral from 1 to 3 of f of x dx equals 4, and the integral from 3 to 7 of f of x dx equals 2. What is the integral from 1 to 7 f of x dx equal to?
3.
No,
1.
6.
6.
Because you just,
Right, and just add them together. Because 1 to 3 plus 3 to 7 is the same thing as 1 to 7. So if 1 to 3 is 4 and 3 to 7 is 2, then 1 to 7 is going to be these two added together. Can you follow that? Because that right there is what third hour had the most problem with, was that property. So any questions on that property, anything I can do to clear that up? Alex, you give me a look.
And then
It's mud, man.
If it's broke, it's fun.
AD for me.
Let me try something else. Alright, so let's say I have 1, 2, 3, 4, 5. Okay, so let's say the integral from 0 to 2 of f of x dx. The integral from 0 to 2 would be that area right there, correct? Okay, and then let's say I have the integral from 2 to 5 f of x dx. So 2 to 5, 3, 4, 5. That would be that. Doesn't it make sense that if I want the integral from 0 to 5, what would I need to do with these two pieces? Add them up. So that's all this is saying. If I've got 0 to 2 and I've got 2 to 5 and I want 0 to 5, I just need to add these two pieces to get the whole. That's all that property is saying. Okay, let's say I have the integral from 0 to 5 of f of x plus or minus g of x dx. That right there is the same thing as the integral from 0 to 5 of f of x dx plus or minus the integral from 0 to 5 of g of x dx. Any issues with that?
What?
there's
Did you just like distribute?
It's kind of like that, yeah. If I've got, what it's saying is, if I've got a definite integral made up of separate functions that are added or subtracted, I can separate them into different integrals. That's what's going on with that. Okay. All right, so let's put these to use. So let's go back to our notes page, and let's look at the bottom of page 1. So they're giving me some facts across the top. They're giving me 3 definite integrals, and they're giving me the values of those 3 definite integrals. And then it wants me to use those values plus my properties to figure out these definite integrals, if possible. Some of these will not be possible. So the integral from 4 to 1 of f of x dx. Brock, what do you think that one is? Part A, integral from 4 to 1 of f of x dx.
3.
3?
I don't think I'm right.
You're not.
I'm not. Couldn't be.
It is 2.
Oh wait, my bad.
Why is it 2, Brock?
Because you switched them.
I switched the order of my limits, and when I switch the order of my limits, I've got to change my sign, so that's why it's 2. All right, the integral from -1 to 4 of f of x dx, Logan. -1 to 4 of f of x dx.
Three.
3 is correct. And again, that's the one we were having most trouble with last hour.
That's the one I thought the last one. That's what I thought the last one was.
Right. Everybody understand why that's 3? Because the integral from -1 to 4 is going to be -1 to 1 plus 1 to 4, and when I add these two together, I get 3. Okay. All right, part C, Harrison. -1 to 1 of 2 f of x plus 3 h of x dx. What would that one be?
$31.
31 is correct. Very good. Any issues with 31? Because we did 2 times 5. 2 times 5 gave me 10. And then we did 3 times 7 gives me 21. 10 plus 21 gives me the 31. Everybody okay with that?
Yep.
All right, Chelsea, what do you think about part D, the integral from 0 to 1 of f of x dx? Pauline, what do you think about that one? 0 to 1 f of x dx.
I don't know, I would just go with like
Sam?
1.
Rock?
I was gonna use that.
Can't find it.
Not possible.
That's
Oh.
I didn't know you could have those.
I told you there were some of these that wouldn't be possible, and it says impossible. Why is it not possible?
Because it doesn't give you a range.
Yeah, I don't have a limit. In order to find that, I've got to have something up there with a limit of 0. And there is nothing up there with a limit of 0. So what about part E? That one also is not possible. I don't have the limit of -2, and I don't have the limit of +2. And what about the last one, -1 to 4?
It's not possible because you don't have one for H.
Right, I don't have a limit of 4 for H. I can do the f of x parts, but I can't do the h of x parts. So those bottom 3 are not possible. Next page. All right, Shanine. A on the first one, the integral from 2 to 2 of g of x dx. 0, very good. 2 to 2 of g of x dx is 0.
How do you get that?
How do you get that, Shanine?
It's like
Oh.
Yeah, whenever the limits are the same, it's going to equal 0. All right, part B. Alex, what'd you get on part B? 5 to 1 of g of x dx. -8 is correct. Any issues with -8? Part C, the integral from 1 to 2 of 3 times f of x dx. Erica,
-12.
-12. Any issues with -12? Part D, the integral from 2 to 5 of f of x. This is the toughest one of this group.
Not possible.
It is possible. Brady, what is it? 2 to 5 of f of x dx.
2.
Nope,
Is it 10?
it is 10.
Oh, I see, because it's
You switch it, so you switch the sign before and then
So 1 to 2 and 1 to 5. So 1 to 5 is 6 and 1 to 2 is -4. So what do I have to do with those two values? I've got to subtract them. So 6 minus a -4 is going to give me 10. See? Here's another way to think about it.
6 minus -4.
You do like that.
You can just switch the sign.
That's these two. So you do
But you don't say.
5.
You can say whatever you want. There's more than one way to do things. There's more than one way to do that.
Okay, that, but you can't just always switch the sign.
It's the same, if you minus and negative.
Not if it's a positive.
All right, so let's look at this.
It's just feeding-
If I want the integral from 1 to 5, 1 to 5 is the same thing as 1 to 2 plus 2 to 5. Is everybody buying into that?
Yeah.
Okay, and I'm interested in finding 2 to 5, so I'm interested in solving for that. Do I know what 1 to 5 is?
Yes.
Yes, I know that's 6. Do I know what 1 to 2 is? Yes, that is -4. So if I want to get that piece by itself, what do I have to do with -4? I have to move it to the other side, which makes it 10. Okay. That's the hardest one we do. All right, E, Logan. Integral from 1 to 5 of f of x minus g of x.
-2.
-2 is correct. Any issues with -2? Samantha, F. 1 to 5 of 4 times f of x minus g of x.
Wait, now.
What'd you say?
16.
16 is correct. Because I have 4 times 6, which is 24. 24 minus 8 gives me 16. 3. Rock, the integral from 1 to 2 of f of u du.
Is it just 5?
It's just 5.
You're switching off.
You just change the variable.
The only thing they did was change the variable. It doesn't matter if I change the variable, the outcome's going to be the same. All right, part B. Harrison, integral from 1 to 2 of the square root of 3 f of z dz.
5 times square root of 3.
5 times the square root of 3. C. Pauline, the integral from 2 to 1 of f of t dt. -5. Chelsea, D. The integral from 1 to 2 of negative f of x dx.
-5.
-5. Any questions on those 4? Okay, moving on. Kaylee, integral from 0 to -3 of g of t dt. Negative radical 2. Any issues with that one? B, Erica, the integral from -3 to 0 of g of u du.
Not possible.
It is possible.
I thought it was a T.
Doesn't matter. If they can change the variables, the outcome is going to be the same. So that one's going to be square root of 2. Doesn't matter what the variables are. All right, Brady, C, the integral from -3 to 0 of negative g of x dx.
Negative square root of 2.
Negative square root of 2. Logan, D, the integral from -3 to 0 of g of r divided by the square root of 2 dr.
It's just one.
1. Any issues with those 4? All right. The last one. I want you to work the last one. I'm going to give you a couple minutes to do it. This is a good AP problem right here, so I want to give you a few minutes to do it. I'm going to come around and see how you guys do. We had 2 last hour that were able to get this on your own, so I'm interested in who can get it on their own.
So it's not A.
It is not A. That was a popular answer last hour. So if you think you got it, let me know. I'll come look at it. But it's a great problem. You're going to have to do a little bit of work. You can't just look at it. Distribute correctly.
Is it top minus bottom?
Winner.
Am I doing this right?
Yes. Finish it.
Like stars.
Did you get it, Brady?
No.
Oh, Brady.
Anybody else
I
want
was planning on you being one of them. All right, let's look at it. First thing we want to do is separate that into 2 different integrals. That's the integral from a to b of f of x dx plus the integral from a to b of 3 dx. We know what that's equal to, right? What's that equal to? A plus 2b. What do I need to do to be able to work that out?
Difference times.
I need the difference of these, which is b minus a, times my constant, which is 3. So that gives me a plus 2b plus 3b minus 3a. Put your like terms together. That's what you end up with.
I would have thought it.
Sounds about right. All right, a couple more examples. All right, on these next problems, they are going to give you a function. They're going to give you the graph of the function, and they're going to give you a region of that function that is shaded. They want you to set up the definite integral that will yield the area that is shaded. So, if I want a definite integral that will yield this area, it's going to be the integral from what to what?
0 to 2.
0 to 2 of what?
8,
That's a 6.
6.
F of
6 minus
X.
3x.
6 minus 3x dx. That definite integral will yield that area. Did you guys see this up here? 6 minus 3x. Okay, what about this one down here? What integral will yield that area?
0 to 2.
0 to 2 of x squared dx. So that definite integral gives me the area of that shaded region. One more. Alright, this one.
0 to 8.
0 to 8 is incorrect.
Oh, that's above.
0 to 2.
0 to 2,
Y.
Y.
y cubed.
Y.
It needs to be dy. Why is that one different?
Because it's above.
The area, where's the area trapped?
It's above.
Between the function and the y-axis. If the area is trapped between the function and the y-axis, I need to be in terms of y. So if I'm in terms of y, it's got to be 0 to 2, and then I've got to be a y here. Okay, on the first two, where was the area trapped?
X-axis.
Between the curve and X.
It was between the curve and the x-axis, and my integrals were in terms of x. So if it's trapped between the x-axis and the function, you use x. If it's trapped between the function and the y-axis, you need to use y. Alright, so I want you to finish up 8, 10, and 12 from the worksheet on the first page in the middle. 8, 10, and 12 in the middle section of the front side of the worksheet. And then I want page 278. I want 13 to 19 on. I want 22. And then I want 33 to 44 off.
What's the square root of 18 minus the square root of